Hi, welcome back to Lussac Chemistry. Today we're going to talk about, again, Gay-Lussac's gas law, lesson C, and we're going to be working two problems in this lesson. Okay, first of all, let's look at the problem. I always kind of enjoy reading these problems because sometimes they're pretty ridiculous. Look at this one. A gas sealed in a cylinder has a pressure of 30.1 atmospheres at a temperature of 100 K. That's actually pretty cold. Because remember that 273.15 K is 0 degrees Celsius, which is 32 Fahrenheit. So this thing is pretty darn cold. It must be out past the orbit of Neptune or something. All right, anyway, so the cylinder is then exposed to sunlight, and the temperature rises to 12,000 K. Man, that is ridiculously hot. What is the new pressure? Okay, well, let's assume that the cylinder is not going to explode or something. So let's look at, we go P1 over T1 equals P2 over T2. So we like to write P1 T2 equals P2 T1. And remember that temperature has to be in Kelvin, okay? That's really important. All right, and if it's not, you're going to use K equals C plus 273.15. Oh, come on, that's really simple. All right, now, so first thing I want to do is I'm going to write P1 T2 equals P2 T1. All right, so now I go P1 T1 P2 T2. All right, let's go ahead and let's find out who's who, okay? So a cylinder has a pressure of 30.1 atmospheres. Now, do we need to convert that into pascals or kilopascals or something like that? No, absolutely not. We can do any pressure we want as long as we keep the pressures the same, but Celsius cannot be used. We have to use Kelvin, okay? That's very important. All right, the temperature is 100 Kelvin. Brr, that's going to be cold. And then, let's see here. We want the new pressure. Okay, and 12,000 Kelvin. Notice I don't use commas. They don't use commas in the international systems of measurement, so we're not going to use them. So we want to isolate for P2 in this case. So that means T1 is going to come underneath here, right? So P2 equals P1 T2 over T1. All right, so P2 equals 30.1 atmospheres times our second temperature actually, 12,000 K. Wow, that's pretty hot. Okay. All right, and divide it by 100 K. All right, that's okay. So K's cancel out, and all we have left is atmospheres. So that's what we're going to solve for. Very easy. I kind of like these gas laws. They're pretty common sense. So we got 12,000. Okay. Okay, that gives me 361,200 ATMs over 100 ATMs. So we're going to divide that by 100. Wow, I hope that cylinder is pretty darn strong because you're looking at 3,612 atmospheres. Hey, just for heebie-jeebies, you don't know how pounds per square inch that is? Well, if you wanted to know that, you could actually solve that by going, okay, we've got 3,612 atmospheres. Oh, I can't talk. Times 14.7 pounds per square inch. And you divide that by 1 atmosphere. That's the conversion. And let's see what that would be. I'm just kind of curious. Times 14.7. Wow, 53,096.4 psi. Talk about being crushed. All right, let's look at our second problem here. So let's go and clear the drawings of this one. And we're going to write our second problem. Okay, a container contains 1 liter of methane gas at 1.2 atmospheres. The temperature is 20 degrees Celsius. What will the new pressure be? Oh, let's put that B in there. If the temperature is raised to 92 degrees Celsius. I know, you're tempted to just leave the temperature in Celsius because they're both Celsius, but you can't do that. Hey, also, we're getting a volume in here. Does that mean anything? Well, not really, because think about that. If you were talking about a volume change, you'd be using Boyle's law. Nowhere in this statement does volume change. so volume is still constant. So that's really, really important to take a close look at when you're trying to decide which gas law to use. All right, so we got P1 over T1 equals P2 over T2. So P1 T2 equals P2 T1. All right, remember that temperature has to be in Kelvin. Ooh, so we're going to need to use K equals C plus 273.15 here. Okay, so let's go ahead and set up what we know. So we're going to go P1 T2 equals P2 T1. So we go P1 T1 P2 T2. Okay, dokie. Yes, sirree. So let's go ahead and do this. Okay, our first pressure is 1.2 atm. That's okay. Our first temperature was 20 degrees Celsius. Ooh, got to change that one. We're looking for the new pressure. And what's our new? Oh, our new temperature was 92 degrees Celsius. Oh, I can't have that one either. So it looks like we're going to have to do a double conversion. So let's go K equals 20 plus 273.15. That's going to give me 293.15 K. So that's our first temperature. So we're going to change that to 293.15 K. Okay, let's look at our second one. K equals 92 plus 273.15. Ooh, what's our new temperature going to be here? So let's see here. 92 plus 273.15. It's going to be 365.15 K. Okay, so we'll get rid of that. This will give me 365.15 K. Okay, let's see here now. So now all we have to do now is find for P2. That means T1 is going to go underneath these two guys. So we're going to write this as P2 equals P1 T2 over T1, kind of like we did in the last problem, right? So we go P2 equals, our first pressure was 1.2 atm, and our second temperature was 365.15 K. All right, so we're going to divide that by 293.15 K. This is okay. Get it? K? All right, anyway. Kelvin, Kelvin, Kelvin. So we cancel our kelvins there, and so we're simply going to plug this into our calculator. All right, so we get 1.2 times 365.15, and that's going to give me 438.18 atm time on top, divided by the 293.15 on the bottom. So divide that by 293.15. And we get, oh, give me the answer, come on. I think my calculator just messed up. Yep, my calculator messed up. Hang on, guys. Okay, so let's see here. All right, divided by 293.15. And this gives me 1.49 atmospheres. And guess what? We're done. So you guys have an amazing day, and we'll see you back here at Lussac Chemistry. Not be amazing, be snarly.